Welcome to the Explainer. Okay, today we're diving into this completely wild 2,000-year-old scientific mystery about how the universe actually works. This is a story driven by stubborn human biases, truly hilarious mathematical workarounds, and some brilliant, albeit highly eccentric historical figures. We're going to look at how a simple obsession with perfection led some of the brightest minds in history down a 2-millennium rabbit hole.
Section 1, The Wandering Planet Mystery. The problem in the night sky.
So, picture this. Ancient stargazers are looking up at the night sky, right? And they notice something very strange about how certain bright objects move against the backdrop of the stars. In fact, the word planet itself comes from the Greek word planetes, which literally translates to wanderer. But why do these wanderers sometimes appear to slow down, stop, and actually loop backwards in the sky before moving forward again? This meandering behavior was a massive problem because it entirely violated a strict rule laid down by the philosopher Plato. Plato had declared that the universe was elegant, and therefore planets simply must move in geometrically simple, perfect circles. No exceptions.
Section 2, The Spirograph Solution. A 2,000-year geometrical hack. To fix this incredibly annoying visual problem without abandoning Plato's beloved perfect circles, a brilliant thinker named Apollonius rose to the challenge. He devised a system that kept the Earth firmly anchored right at the center of everything by inventing the epicycle. It's literally like that old childhood toy, the spirograph, where you roll a small cog with a pen inside a larger ring. Apollonius theorized that a planet rotates in a small circle, an epicycle, which simultaneously rotates along a much larger circle centered on Earth. This clever, doily-like orbital path mathematically explained exactly why planets appear to occasionally reverse direction from our point of view. But here's where it just gets completely out of hand. By the 2nd century CE, the Greek astronomer Ptolemy had universally established this model. But to make it actually match observations of the sky, he had to keep adding more and more circles. Eventually, his final version required a dizzying 39 cycles and epicycles just to map the paths of the 5 known planets, the Sun, and the Moon.
Plato's dream of elegant geometric simplicity had morphed into this bewildering, confusing mess of circles spinning upon circles. It was so bad that it prompted a 13th century Spanish monarch, King Alfonso the Wise, to exasperatedly mutter that if God had consulted him on creation, he would have recommended a much simpler design. And honestly, you kind of have to agree with him.
Section 3, The Homer-Simpson Orbit. Why Bad Theories Survive. Now, you're probably wondering right now, how exactly did such a clunky, overly complicated, and ultimately wrong theory survive entirely unchallenged until the 16th century? Why didn't anyone see the flaw? Well, it survived because the epicycle theory is mathematically bulletproof in the weirdest way possible. It was never falsified because it literally cannot be falsified. In 2005, 2 Argentinian scientists set out to prove this point. They chose an outrageously complicated, non-astronomical path to trace. By calculating a massive deferent and exactly 9,999 epicycles rotating within one another, they successfully created a mathematical orbit that flawlessly drew the outline of Homer Simpson. Yeah, by stacking 10,000 circles, they perfectly traced a cartoon character. This brilliantly demonstrated that the phrase adding epicycles, which is actually used in modern science as a derogatory term today, just means you're endlessly refining a mistaken theory by adding variables in the stubborn hope that'll eventually work. The idea was so adaptable that nobody bothered to look for the actual truth. Section 4. The Eccentric Astronomers. The Odd Couple of Astrophysics. So the massive paradigm shift humanity desperately needed finally kicks off with a German named Johannes Kepler. Kepler was a fascinating character. He was a hypochondriac with crippled hands, continuous skin ailments, and a brilliant, absolute obsession with numbers and the stars. He firmly believed the planets revolved around the sun, but he was still trying to force their orbits into complex geometric shapes. He ends up appointed as an assistant to Tycho Brahe, and Brahe, oh man, Brahe was a flamboyant Danish aristocrat who sported a gold and silver prosthetic nose because he lost his real one in a sword duel over a math formula. He even had a pet elk that tragically died after drinking too much beer at a dinner party. I mean, you can't make this stuff up. But beneath all this absolute craziness, Brahe possessed one crucial thing: the single most accurate astronomical data in all of Europe. Brahe recognizes Kepler's mathematical genius, so he entrusts him with the most painful, laborious task in the observatory, deciphering the specific orbit of Mars. Mars was the ultimate headache for astronomers because it was the planet that most stubbornly wandered away from any predicted circular path.
Section 5. Breaking the circle. Letting go of Plato's ghost. Kepler declares he is at war with Mars and is deeply determined to solve it. But just like everyone else in history after that point, Kepler is still mentally trapped by Plato's absolute assumption that orbits had to be perfect circles. After checking predicted positions against Brahe's observed data at least 70 different times, 70, and completely exhausted by his inability to make circles work, he finally just snaps. He decides to completely ditch the 2,000-year-old theory of epicycles. He dramatically laments that he had cleared out the messy spirals of ancient astronomy, leaving behind only a single cart full of dung, a messy, unknown orbit. So, circles failed him. For a whole year, he experiments with an egg-shaped orbit, an oval with a flat end and a pointy end. He actually found the shape physically repugnant. But to make approximating the messy math of the egg a little easier, he temporarily uses an ellipse as a geometric prop. And then boom, suddenly it clicks. The prop could stand alone. The ellipse itself was the exact answer. This realization gives us one of my favorite quotes. He writes, "O me ridiculum, how ridiculous of me." Because, get this, Kepler had actually discarded the ellipse much earlier in his process. Why? He genuinely thought it was far too simple an idea for thousands of years of previous scientists to have somehow overlooked. Section 6. The new cosmic focus. The elegant truth. The ellipse finally solved the mathematical nightmare of planetary orbits, cleanly and elegantly matching Tycho Brahe's incredibly precise data. But to fully accept it, it required one massive conceptual leap to truly make sense of our solar system. Unlike a perfect circle, an ellipse does not have a single dead center. It has two focal points, or foci. This initially troubled Kepler, because if the sun was the center of the universe, why would there be two focal points? Then he realized the mind-bending truth. The sun isn't in the exact center of the system. It sits at just one of those foci, and there's absolutely nothing at the other focus. It's a total revolution. We evolved from an Earth-centered model demanding perfect circles and constant speeds to a sun-focused model with squished elliptical orbits. And because the sun is off-center, a planet's speed isn't constant at all. It actually moves faster the closer it gets to the sun's gravitational influence, sweeping out equal areas in equal times. And here is a wonderful, almost poetic twist of scientific irony to wrap this up. The ellipse, the shape that finally destroyed the epicycle, was a curve that had been studied deeply in antiquity. In fact, the very man who invented the wrong 2,000-year epicycle model, Apollonius, was the exact same great geometer who had originally named the ellipse and knew its mathematical properties better than anyone else alive. The answer was literally right there all along. Philosophers have called Kepler's breakthrough the boldest exercise in imagination ever required in the history of science. It snapped a 2,000-year chain of dogma. So as we close this explainer, I want to leave you with this provocative thought. What perfect circles are we stubbornly clinging to in our own modern thinking today that might just be a simpler, messy ellipse waiting to be discovered? Thank you for joining me on the explainer, and keep questioning the perfect circles in your life.